Hello everyone. Today I took a Lammps crack file and today I'm going to explain the every command of this Lammps file, and I will also show you how to run a Lammps code in your computer. Let's start. In here I have two a example file named in.crack, and you can see at first we have declared dimension is 2. That's because we are using a 2D structure. If we want to use a 3D structure, then we will use the number of 3. And you can see boundary is SSP. That means in x axis we are using S, and y axis S, and z axis is P. And what does S and P means? You can see here the style P means the box is periodic, so that the particle can easily enter and exit from the box. They can move from one phase to another. If I explain it, let's just imagine that it is our simulation box, and there are many particles or there are many atoms here, and am applying a force F here. For the force F, the one atom from this simulation box will leave this box, and finally for periodic boundary it will come to its initial position. That's why you will see this structure again, and we can say that total number of atom in this simulation box will be constant for periodic boundary. And for style is the position of the phase is set and atom only move in that dimension. Here atom cannot move freely. If I explain, let's see here again. Let's imagine that is our simulation box, and we are using a force F here. For this force, this atom will change its initial position, and as we mentioned that for style S, here the atom cannot move freely. That means the atom cannot leave this simulation box. So its final position will be like this. And for style F, the atom will move and get lost from this simulation box. That means total number of atom will decrease from this simulation box for F type. And now the atom style atomic, and what does it means? It define what style of atom to be used in a simulation box. If I go to Lammps documentation, here you can see that we can use many types of atom style. You can use atomic, bond, full, and etc. For atom style, we will use atom style atomic for coarse grain, liquid, solid materials only. And if we use a electric force field, then we will use atom style electronic, and etc. Okay, next command is neighbor 0.03 bin. That means here an atom can effect up to 0.3 distance from its cutoff radius. Neighbor modify DL of 5. That means here our program is checking whether any dangerous is built or not after 5 time steps. Okay, now we are going to create our geometry. in here lattice hex, and hex means we are using we are going to create a three-dimensional geometry. That's why we are using a we are using hex. If you want to use 2D simulation box, then we will use SQ, SQ2 and etc. And the edge of this simulation box is 0.093. Okay, and after it we are going to declare a region of this simulation box, and the limit of x-axis is 0 to 100. Limit of y-axis of the simulation box will be 0 to 40, and limit of z-axis will be minus 0.25 to plus 0.25. After declaring a region, we are going to tell Lammps that what types of atom we will use in the simulation box. That for that we are going to we are using the command create box 5. That means we are using 5 kinds of atom. You can see we have already declared that mass of atom type 1 is 1, and mass of atom type 2 is 2, and mass of atom type 3 is 3, atom type 3 is 1, 4 1, and mass of atom type 5 is 1. That means we are using 5 types of atom here, and then we are creating the box create atom 1 box. We are declaring that all those type of atom will be in a box, in one box. Okay, then comes our potential. We are using LJ potential. LJ means linear joule potential, and we will use this command pair style. Then we'll write what kind of potential we're using. It could be LJ, it could be Fasista, it could be EAM and etc., or it could be min and etc. etc. Pair coefficient, and these indicate the potential of the linear joule potential. It is acting as a potential file here. Okay. Then we are defining a group of the simulation box. Okay. In here, where we are declaring that we are again declaring a region number 1 block, and the limit of region 1 is in x-axis infinity to infinity, y-axis infinity to 1.25, and z-axis infinity to infinity. That means if it is our simulation box which we have already declared earlier, then I am again declaring a region where x-axis is, let's say in here it is our x-axis, and in here it's our y-axis, and z-axis is the another side, and x-axis is from infinity to infinity, and y-axis to is from infinity to 0.125. That means 0.125. That means it is our region 1. And after declaring our region 1, we are going to tell Lammps that we are taking the region 1 in lower region, in lower group. That means this will be our lower group. Then we are again declaring a region 2 where x limit is infinity to infinity, and y limit is 38.75 to infinity, and z is infinity to infinity. That means it is 38.25 in here, sorry, 38.75 to infinity. That means this will be our region 2, and we are declaring that region 2 will be in group upper, that means it is our upper group. And in next line, group boundary union lower upper, that means you are telling that these two group, that means upper and lower group will be in another group that which will be named in boundary, that means these two group will be in boundary group. Then again we are creating a mobile group and mobile subtract all boundary, that means mobile subtract all, that means we are subtracting the upper and lower group from total of the simulation box, and our uh, mobile group will be in the middle part, it will be our mobile group. Okay, that in here mobile region is defined here. And in after it we are again declaring a region left upper block, uh, x axis is infinity to 20, y axis is 20 to infinity, and z axis is infinity to infinity, that means here some here it will be like this, and that will be left upper and left lower group like this, or something like that. Okay, and we are setting the group left upper type 2, group left upper type group left lower type 3, group lower type 4, and group upper type 5. After it initialing we are initialing velocities using compute command, and we in compute command it is written that new mobile temp, this command compute global, local, and per atom quantities of an atom. Global quantities means temperature, per atom means kinetic energy, and local means list of bond distance. In here we are computing temperature, where we are computing temperature of the mobile region. Velocity mobile create 0.01, and it's a random number, and temp new, that means we are going we are creating a temperature 0.01 in the mobile group, sorry, in the yes in the mobile region. And velocity set upper set 0 0.3 0, that means in upper region we are setting a velocity 0.3 in y axis, and velocity mobile ramp vy x in limit is 0 to 0.3, and limit of y is y axis is 1.25 to 38.75, and we are after it we are doing NVE integration, and after that we are going to fix the boundary set force 0, that means boundary set force null from is 0 to 0. Here we have already declared two boundaries, which was upper and lower in our previous command. In here we are already declared that boundary will be in the lower and upper, that's why we are we are using this command again, the boundary set force, that means we are going to set the force of upper and lower region is in 0. In this boundary we are taking force 0, that means the atom in that boundary will not move with respect to another. Here comes our run part. In here time step we are using time step 0.003 and thermo 200. That means after 200 step we will see our result. And if we remove the hashtag, then our file will be dumped, otherwise it won't be dumped. And finally we are running for 500 times, sorry, 5000 times. Okay, now I'm going to show you how to run this command. I already copied it from example file and paste it in a local file, and I renamed it as m.crack, but all the things is same. At first click here and I will type cmd, write lmp serial in, and our name of the file was m.crack. Press enter and it is running. Okay, just look here, it is running for 5000 time, because we dumped it, we run it for 5000 times in our Lammps file. And you will see a dump file has been created here, and we will visualize this in Ovito. I am opening my Ovito. Just drag the dump file and you will see the upper region. That was the upper region, that was the lower region, and that was the upper left, and that was the upper lower. That was the upper left and that was the lower left, and all of these was in mobile region. Okay. And this region was our boundary region. Okay, and we set the force of the boundary region is 0. Okay, and if I run it, then you will see it is cracking. Okay,